topic, as you know, when we have been discussing with our topic number, chapter number 4, so chapter number 4, that is known to be chemical kinetics, right? Chemical kinetics means the topic which deals with the speed of the reaction, the rate of reaction, and many more things, right? So in this particular topic, as you know very well, we have been dealing with the order, with the molecularity, and we have completed zero order as well as first order. Clear? In our previous class, I have just completed the first order kinetics, its integrated rate equation, and moreover, I have put some efforts to make the half-life period of that particular reaction, which could not be completed at its moment. Okay, so I'm just going to re-revise the topic within a minute, and then we will have some examples on the basis of first order kinetics. Okay, let's start. First of all, as we know, in our previous class, we have just completed that T half for my first order kinetics is found to be 0.693 upon K. That means my T half is independent of the concentration of the reactant, right? That's the answer we have got for the first order reaction. But if I'm talking about zero order reaction, my answer was R0 by 2. That means my half-life period that is directly proportional to the concentration of reactant. Okay, let's have a simple example on this. But before this, I just want to compile both the reaction zero order as well as first order in the terms of half-life and their integrated rate equation. Let's have a quick recapitulation of that particular topic. Okay, first of all, I just want to tell you, this is my reaction. Reactant is converting to product. Okay, if I'm talking about the zero order, what would be the differential rate flow? It would be dr upon dt equal to minus k. Why? Because r to the power 0, that means 1. This is for zero order and another one for first order. Okay, dr by dt equals to minus. This is my differential rate equation. If I'm talking about the integrated rate equation, the equation tells me we have got Kp equals to R0 minus R. Clear? Same as it is, we have done differential equation, we have done integrated rate equation, and we have also told you that the rate, the graph was done between the R versus T. Half-life period were R0 by 2K. And finally, the unit would be mole per liter per second. Why is it so? Because we know that the concentration K has the formula concentration to the power 1 minus n per second. Okay. So it would be mole per liter minus 0 per second, that is mole per liter per second. Okay. Same as it is for first order reaction, the reaction is same, but it says something minus K R, right? Because in first order reaction, my reactant concentration is 1 which depends upon the reaction. And if I have told you about the differential rate law, sorry, integrated rate law, we have got ln R upon R0 equal to minus Kc. So हमने इसको further solve किया था and we have got the 2.30 kilo R upon R0 and so on. Okay. But the point of interest for me right now is I haven't told you about the exponential equation. For the first order kinetics, we have another term, exponential equation, which tells us whenever I just multiply both sides with e, that is exponential, what would happen? It would be cancelled out and we will get r equals to r0 e raised to power minus kc. This is again a mathematical equation, बच्चे. Whenever my logarithm and exponential they are combined together, they just cancel out each other. Because E means 1 over ln, yani 1 over ln into ln, that will be cancel out. So overall I have the equation r equals to r naught e raised to power minus kt. Clear? Now I've been talking about the graph, but the graph was between the time versus ln r by r naught. What is my half-life period? That is 0.693 upon k. What is the unit? That is only per second, because mole per liter 1 minus 1, it will be equal to the power 0, that will be equal to 1. Clear? So this was all about, we have studied about this thing, and we have got the concept. You can write this equation, you can write this table, so that, or you can expand this table in your own ways to just memorize all the formulas. Okay? Because in chemical kinetics, we have only these formulas which will solve you, which will grade you to the marks in your board exam. Clear? Okay. So before moving to the next topic, today I just want to have solve some questions, some queries regarding the first order kinetics. It could be its half-life period, or it would be depend upon this particular reaction. Okay, let's have a look. Just today we'll solve some examples, then we'll go to next topic. Okay, first of all, there would be a simple question on the basis of half-life period. Let's see what question asks to us and how can we solve it. The question is on page number 109. That is your NCERT in-text question. The question is, a first order reaction is have a rate constant K equals to 5.5 into 10 raised to power minus 14 per second. Okay. पहली बात तो ये, अगर हमें मेंशन नहीं किया है my reaction is first order, I still can tell this is first order only by checking out the unit. And the question has been asked, already tells us that first order reaction is over there, we have the rate constant, and we have to just calculate the half-life period. What would be the half-life period of that reaction? That means T half we have to calculate. So we can easily solve it by T half equals to 0.693 upon 5.5 into 10 raised to power minus 14. You will solve it and you will get answer in seconds. Okay? This was all about this particular question. Let's have another question that's very important, and you must have that in your mind, because these type of questions will definitely 110% would come in your board exam as well as competitive exam. Okay, let's have a look. The question has been asked, show that the first order reaction time required for completion of (99.9%) is 10 times of half-life of the reaction. That means T half of the reaction. Okay. First of all, the question, when you see it seems to be half-life period. That means हमें half-life दिया, we will just put the formula and we will get the answer. But the question has been asked that we have given two different type of timing. First one is 99.9%, second one is 50%. Okay, so the question will not go through with this formula. This will go with the basic formula of first order kinetics. दोबारा सुनो, we have two different timings. First one is 99.9% reaction is completed. Second one is half life. That means my reaction is 50% completed. Okay, so we have two timings. Another point was say, as we have seen, it could be rearranged as 100. हम इसको ये बोल सकते थे कि हमारी reaction complete हो चुकी है 100% का, and reaction is 50% complete. We have to compare the two. But the question asks 99.9%. That means chemical kinetics is so much accurate. This is the beauty of chemical kinetics, that we can easily calculate these type of reactions, their speed at a particular time. Okay, so just enjoy this topic. The question asks, we have to tell two different type of reactions. Okay, first of all, as you have two different type of concentration, we can easily write out the formula 2.303 log R naught by R. Okay, now the point is, how do we write 99.9%? First of all, log R naught means section concentration is same. We haven't given any R naught, so we write it R naught as well as. But 99.9%, that means 99.9% the concentration has been reduced. दोबारा से I'm saying my reaction has completed 99.9%. अगर मैं बोलूँ कि मेरी reaction 80% complete हो चुकी है, that means my concentration R is now R naught minus 80 R naught, I can say. मतलब हमें ये बोलना चाह रहा है ये कि हमारी जो concentration है reaction की वो 80% already complete हो चुकी है. In the very same manner, if I'm saying 70%, 60%, we have the 99.9% also. Okay, so we can say that my R for 99.9% would be R naught minus 0.99 R. Do you get my point or not, बच्चे? I have just taken R naught equals to 1. So for removal this percentage concept, I will just, ये भी हमारा change हो जाएगा 0.80. It will be become R equals to 0.99. Okay. So now after completion this reaction, after we have got the particulars, we can easily solve it. It would be become R naught minus 0.999 R. Am I clear or not? मैं दोबारा बोल रही हूँ, when we have done 99.9% reaction is completed, that means the concentration of reactant is now reduced by 99.9% of the initial concentration. That's why I have written R naught minus 0.999 R. Now for removal the percentage, I have just divided by 100. That's it. I haven't done anything extra. Okay. So let's move with the topic. We can easily solve it by R naught. This is 1. This is the 0.001 R naught. Definitely yes. Or we can write it R naught 1 by 1000 R naught. Yes. We can cancel out the R naught, or we can write K is equal to 2.303 upon C log 1000. This 1000 is at the lower side, this would be at the upside according to mathematical equation. So that's it. Now have another look. This time given to us. Okay, no. 1000 means 10 raised to power 3. Yes or no? Definitely. 1000 means 10 raised to power 3. And according to the formula of log, if we have log m raised to the power n, we will get n log m. Right? So from those particular terms, when we have log m raised to power n equals to n log m, we can easily say that it would be become 3 multiplied 2.303 upon 2 log 10. हाँ या नहीं? Definitely लिख सकती हूँ मैं. And you know log 10 equals to 1. Log 10 means 1. So after solving this, suppose this is becoming 326.909. Clear? Okay. Now I have just done only half of my reaction. I would like to say I have just completed half of my question. 99.9% I have solved. Now I have to solve for the 50%. Let's solve this particular question again. I'm just going to. Okay. So we have done k equals to 6.909 upon t. This was the question given to us. Or we can say, because we have to compare, na, p equals to 6.909 upon t. Now the question has been asked to us half-life period of the reaction, that means 60% of reaction is completed. So can we write T half is equal to 0.693 upon T? Definitely yes. हमें पहले से पता है उसका formula, so we do not need to require to solve it. Now we have to just compare these two so that we can say that my reaction of 99% completion is 10 times to the T half. So compare करने के लिए हम क्या करेंगे? I'm just dividing the two equations. T by T half equals to 6.909 K upon 0.693 upon K. The K would be cancelled out, and T upon T half equals to 6.909 upon 0.693. This seems to be almost 10, 6.9 and 0.69 almost 10. So T equals to, so T upon T half equals to 10. Now T equals to 10 T half. Am I clear or not? The question was easy. The question was a little bit productive. And the question was, we have to prove that the time required for 99.9% completion, what I'm writing here, 0.999, is equal to 10 times of the half-life period of the reaction. Right? So we have proved that. Okay, so this was the question, easy question and very productive question in which we have used all my formulas, this one also, and we have done the logarithm calculation also. Okay, so this was all I wanted to explain to you. Let's move to another simple question. And then we will move to our next topic, that is pseudo first order kinetics. But before this, just have a single one more question. The question is, this is the question. This is unsolved question. In your in-text question, this is going to be. Okay. The question is, a first order reaction has a rate constant K equals to 1.15 into 10 raised to power minus 3 per second. And the question is asked, how long will 5 grams of the reactant take to produce 3 grams? Okay. That means how long, मतलब हमें time पूछा गया है. The question does not tell us that this is the first order reaction, but the unit tells us that this is our first order reaction. Okay, so we will just simply put K equals to 2.303 upon T log R naught upon R. R naught is my 5 because this is my initial concentration, right? It has asked 5 grams would convert to 3 grams. So 5 upon 3, definitely yes. Okay, and we have to calculate T, so we can say 2.303 upon 1.15 into 10 raised to power minus 3, which would be 10 raised to power plus 3. Log m divided by n means log m minus log n. Okay, and one more point, but say I have told you in previous class, please remember these three quantities. Log equals to 0.3010, log 3 equals to 0.477, log 5 is equal to 0.53. I'll just put it down in your notes. I do not remember exactly this particular quantity, but you can remember that very well. Okay, I'll just write down in your notes also. Suppose this is 0.5 minus 0.477, and you can solve it and you will get the time required. Okay, now my point of interest is, let's say you have done 2 to 3 questions, 90% in your board exam, you will get only these type of logarithms. Why? Because the examiner also know logarithm table providing is very difficult, plus calculator is not allowed. Do not bother yourself too much, but remember these 4 to 5 quantities. Log 10 equals to 1, log 0 equals to so log 1 equals to 0 and many more things. Okay, so that you can solve it easily in your final examination. Okay, this was all I wanted to explain to you. All right. Okay, so till now we have completed two types of reaction, that is zero order and first order kinetics. Okay, and in zero order and first order kinetics, we have done the integrated rate equation also, we have done the differential rate equation also, the time period as well as the unit also. Cool. Now, the point of concern is along with zero order, first order, there are so many reactions like second order, third order, but they are not in our syllabus. So we can take a relief for those type of reactions. But there is another type of reaction known to be pseudo first order reaction. So today we will discuss what is pseudo first order reaction. Okay. First of all, as the name suggests, or you can check it out, this is somewhat which is related to first order, right? मतलब अगर वहाँ पे pseudo बोला है, that means first order से कुछ ना कुछ तो मिलता जुलता है. The pseudo means false, or we can say hypothetical, or pretending, we can say, right? Hypocritic, we can say any word. Pseudo is something like we are talking about an elephant. You must have seen the elephant either in zoo or in book or somewhere else. I just want to tell, we say that elephant has two different types of teeth. One are very long, which are also called as tusks, and another one that with the help of which he eats. Okay, those teeth which are just represented as a teeth, they are known as pseudo teeth also. Okay, so in short, I would like to say pseudo first order reaction is false first order reaction, यानी नकली first order reaction है. It seems another type of reaction, but overall it would finally become a first order reaction. Let's see how. Now, for making this topic clear to you, I have given an example. Let's see in the chemistry terms. How do in chemical terms we can say that? Okay. In your book, we have given a very simple method. It says that the order of reaction depends upon many things. You know that very well because it is experimental. Okay. So what happens? We have some type of reaction in which the two molecules are colliding with each other. Okay, I'm just saying that suppose these two molecules are colliding with each other. Okay, I'm saying the concentration of one molecule is very, very excess to another molecule. For example, एक molecule की concentration इतनी है और एक molecule की concentration इतनी है. You can easily say that this one has something excess concentration as compared to this. Okay. For example, let's have hydrolysis of ester. In previous class, I think Vidhi asked me about the hydrolysis of ester. Now Vidhi will get your answer. We are forming acid plus I think there would be alcohol. That's right. Okay. There is hydrolysis of ester. Ester is reacting with water. Now I have just taken the concentration of ester 0.01 mole. Okay. Whereas the concentration of water is 10 mole, I can say, or 10 gram, I would like to say, that would more easy to understand. Okay. So, but you have must understood that the quantity of ester is very less as compared to water. This is almost negligible. This is almost 0 gram. But water is something which is almost 10 grams. So now when the reaction is completing, the ester is reacting with water. It is making acid as well as alcohol. Suppose my 0.01 gram has completely been used and water has been used only 0.01 gram. यानी 10 में से मेरा सिर्फ 0.01 ग्राम ही वाटर यूज हुआ है, जबकि मेरा एस्टर पूरा कंप्लीट यूज होगा. इसके बाद जो मेरा प्रोडक्ट आता है, इसकी क्वांटिटी वी गेट सफिशिएंट. दैट मींस व्हेन द रिएक्शन हैज बीन स्टार्टेड इनिशियली and when the reaction has been completed finally, infinite, my concentration of water does not give much impact on the completion of reaction. दोबारा सुनो, the reactant whose quantity is present in excess and which does not impact, which does not alter many conditions on the completion of reaction, that reaction is known to be pseudo first order reaction. क्यों? क्योंकि हमें देखने में ये लग रहा है कि इसकी जो concentration होगी, that means this and this. Suppose my rate constant, I would like to say, equals to K, ester and water. It seems that the order should be 2, ester and water. But experimentally, we have seen that water do not affect much on the completion of reaction. So my reaction has only one order. That is why we call it pseudo first order reaction. I hope I'm clear, bache, and you have got the concept very easily. Still then, I'll have just one simple example for it. The rate equals to K dash ester and water. Then my final rate would be K CH3 COOC2H5 after completion. Now the point arises why I have written K dash. The query will be solved right now because we have put K equals to K dash water. Okay, so from this equation we can say my rate depends only on the 1 power of a concentration, and hence we call it pseudo first order reaction as compared to second here first order reaction. Okay, so this was all about this particular topic. Such reaction are called to the first order reaction, and another example is inversion of cane sugar. यानी आपके पास cane sugar है. What is cane sugar? Sucrose. That is present in cane sugar is ganna. That is present in cane sucrose. When we react it with water in excess quantity, it would give you glucose and fructose. Glucose and fructose. And finally, the rate would be again K C12H22O11, where K equals to K dash water. यानी इसके ऊपर इसका कोई इफेक्ट नहीं पड़ेगा. So this particular type of reaction is known to be pseudo first order reaction. Okay. Another point about this particular type of reaction, a question has been given to your NCERT textbook. We don't have much time left to solve that particular question, but I just want to explain you that in that particular question we have been given different time and different concentration. Let's have a look on page number 110 in your NCERT textbook. We have been put the question. The question has been given the same equation, ester plus water. Okay, and we have given the different time and different concentration like 0, 30, 60, 80. And suppose my concentration is reducing as 0.85, 0.80, 0.75, and 0.70. And we have to show that this reaction is a pseudo first order reaction. Why? Because the quantity of water, the concentration of water is taken to be 55. This is 0.85 gram, this is 55 grams. That means super excess as compared to this. Okay, so we have to explain that this reaction is pseudo first order reaction. So for solving this equation, we will just do K equals to 2.303 upon T log R naught by R. मेरा कहने का मतलब ये है बच्चे कि my pseudo first order reaction also follows the equation of first order reaction. Pseudo first order reaction follows the same condition, the same method for the first order equation. Okay, for different times, like as for time 0 is not possible, that would be infinite. 30, we will see log R naught is given to us 0.85, R is 0.80, we will solve it. Same as it is for time equals to 60, we will solve it, for 80 we will solve it, And for all these type of reaction, if my K is found to be constant, almost equal, suppose in all these equations it is become 2.004. For T equals to 30. For T equals to 60, it is coming 2.005. For T equals to 80, suppose it is coming K equals to 2.003. That means my K is constant, my rate is constant, my speed is constant. Hence, we can say it does not affect on the water quantity, on the water concentration, and we will say this is a pseudo first order reaction. Am I clear with this? So we have done all the topics.